name is Rachel Phillips. I am with Goodrich Petroleum. I've been there almost a couple years. Recently graduated from Texas A&M University with a bachelor's in petroleum engineering. So the SCADA and automation world kind of took me by surprise, coming from less sophisticated companies and field experiences. So our objective was to take our field and develop an automation solution out of the box to be able to apply to our unconventional oil and gas plays and help us enhance the productivity of our field. And importantly, reduce those tedious tasks that the field guys manually capturing data, improve the accuracy. They seem to think that there's not much error in the readings that they take, and to record and utilize the data more efficiently and effectively, and hopefully realize an increase in our revenue. So what we did, we had a big field study done to really look at the human-centered approach and designed to make everything easier for our guys in the field to use and more valuable for the engineers in the office. So we'll go through what we learned and are hoping to implement. Here's a typical gas lift well. We have the casing, which is a steel pipe, cemented into the ground after the well has been drilled, and then depending on the well configuration, this is an example of gas lift, have tubing installed with pre-designed and pre-pressure set gas lift valves, and we pump gas down the casing and injects it into the annulus to lighten the fluid load to better produce the well. So the important part, once that oil and gas is coming out, which is my job, is to send it through the production facilities and further downstream to the end user. So the oil and gas, depending on the field, and water, go through their multi-phase separation, typically high-pressured separation here. And then the oil goes through heater-treater process to knock off the rest of the water and residual gas. In most of our fields, we haul the water and the oil. One of our fields, we actually have the oil pipelined off. Here's an example of one of our 5, now 6 and about to be 7 central distribution points, kind of a central facility where all the processing is done. The multi-phase flow goes straight to these facilities to be separated and processed. Minimal process, but separated and sent to their respective location. So we have multiple wells on different pads, which is common in the unconventional shale plays, and go through test lines and the bulk line, the wells that aren't in test, and go through separation into the tanks, and we'll go through the more detailed processes. So the field study that was done, the goal was to look at what our current operations, what are we currently doing, what are the guys in the field doing day to day. So they are manually out there. Our facilities were originally designed to be man-powered, and the safety systems were designed to, assuming that there were going to be personnel there 24/7. So here we just have the pumper, is what we call the personnel, monitoring the well, troubleshooting, trying to figure out if the well's flowing good or bad. The test to bulk changeover is done completely manually, turning valves. This is one of our newer facilities, so it wasn't painted pretty yet. And there's a lot of troubleshooting done. We have some minimal diagnostic points and sensors and SCADA available, but most of the troubleshooting is go look at it and figure out what the heck's wrong, and call out the superintendent and have him help you. And it takes a lot of time to figure out if we just had a little better system in place, those pressure readings would be available, or we would be able to see what exactly the problem was before even getting to the field. Same with the heater treater, another kind of complicated big piece of equipment. And we currently have big problems with our dump valves that are all manual dump valves. And then in the Eagle Ford Shale, we pipeline our oil. So we have LACT units, a custody transfer unit that meters and counts how many barrels are going through, and it's on an independent system than our current system to be able to see what those volumes are. So that's another thing that the pumper has to document down and input to the computer system. So the pumper goes along and goes to all of his wells, goes through his respective facility and captures all the data, and then comes back, fires up his laptop and tries to type everything in. We are in South Texas, and our other main operations is in the Tuscaloosa Marine Shale, one of the new Eagle Ford type plays, and we have really, really bad cell service and connectivity issues in both fields. Here's our pretty standard data flow. The data we do capture goes through the SCADA system and into the databases, and then the pumper has to manually enter a lot of the data also. So here's some of I'll go by component to see what our challenges are and what is actually done. I won't read word for word. But general well site, the data flow to our SCADA system is very limited and is often inaccurate because maybe we don't have a good calibration schedule in place yet. The points might be tied wrong to our system. We are a very slim company, and everything we have has been retrofitted after the fact to these facilities. So that's why I am currently focusing on all of our SCADA in all of our fields and trying to get everything lined out and improved. Our separators, both on the test and production, they're handling large volumes of fluid coming through, and their mechanism to get the good oil and water measurement is a constant struggle with multi-phase metering and with the configuration of our field setup. And most of our measurement right now, our volume measurement, is just done by gauging tanks. And we're currently testing the accuracy of some multi-flow meters now, multi-phase meters. The heater treater, that's something that would really optimize our separation process if we could constantly monitor that and control it, and that's something we haven't got a grasp on quite yet, mainly due to resistance from the field and some managerial support of that, just kind of being scared to switch over to the unknown. And a big thing, which was the first thing I focused on, was gauging the tanks. I don't want any manned personnel manually gauging the tanks, because in Eagle Ford we do have high H2S. Mississippi, it's not so much a problem, but we are pretty remote in our operations, and you're out there by yourself. So unless something is wrong with the SCADA equipment or RTU, which is very, very unlikely, it might not be communicating, but the RTU data is still there, they're not to be on top of the tanks gauging. And that was a pretty easy transition, and they were mostly thankful, but I guess they really like to climb up those tanks and gauge them sometimes. Our custody transfer, like I mentioned earlier, is done by a third party, the pipeline gatherer, and we just have manual access to that data, and we haven't started the process to kind of get those numbers tied automatically into our system yet. And then a lot of the other data for some of the other pieces of equipment where we don't have any SCADA equipment or automation equipment yet has been quite a big struggle. And it really hurts the accuracy of their reporting and us tracking downtime and for optimization purposes, which is the most important to add value to our company. So our big goal is definitely to improve our measurement accuracy. We have to be very close to knowing how much oil and water and gas We are making for environmental purposes, for well production, productivity purposes, for our landowner and shareholder purposes, and for our overall revenue. And very importantly, reduce the amount of human error, even though they can be quite prideful in thinking that their processes are currently stellar. Reduce the amount of manual equipment control. We are completely manual right now, and ensure that we are having a reliable system. That way, me in the office and the other engineers, we can say, oh, this must be what's wrong with it, instead of getting some of the information from the manpower and some of the information from the SCADA equipment that both usually conflict very badly. And it's also very important that we do provide the field with proper training for all of these systems. And everything always equals money, of course. One feature that we have an idea of but not fully implemented is the distributed RTU network, to where controller can talk to controller, and it's just a complete full circle integrated communication path. The well will know what's going on at the facility knows what's going on with each of its individual wells. So right now, we have pneumatic safety systems just on the wellheads, and everything else is up to the manned safety theory that we have 24/7 manned operations. So a fully automated well would look like we would have pressure sensors on the tubing and the casing on the flow line. We would have safety valves that would electronically shut in at preset points based on the other components. A choke that we could control electronically, and we are starting to have that, install those on all of our gas lift wells, and that's been really great because I can say open the choke this little bit and increase the gas lift rate to this. But eventually we can plug that into a program that just has an algorithm pre-built into it, and we set the points for that well, the limits of operation, and it just optimizes itself. And with these systems, we will be able to retrofit later and easily add whatever type of artificial lift we might need, whether it's a pumping unit, gas lift, which is pretty popular in a lot of shale plays, hydraulic jet pump, or any other type of artificial lift that we will soon figure out and better optimize with shale production. The well test solution, instead of having the pumpers manually open and close valves and redirect to the lines, and are we sure, I've been out to the field and the lines aren't even labeled, much less, I don't know how they know what pipe goes where, but they are the expert. But eventually there is a little bit of downtime and purging of the lines that causes inaccuracy, and a lot of error that can happen from changing these wells over. So if we had some kind of multi-port changer, that would be awesome. This is mostly used offshore, so I don't know when we might see it onshore. I don't know of any company that onshore that really has this yet, but it's definitely in the future. Here's just a few more words about that. And another big point is with the separator control. Currently we have the pneumatic dump systems that when the separator levels get so high, they just dump automatically. But sometimes those dumps hang and hang open or don't open. And we have a big case to install these electronic valve opening systems. And it would save us a lot of emissions issues and help our separation a lot more. We would be able to separate more efficiently and effectively if it was more accurate and better done. I think the graphic, oh, here we go. Left it in. And same with the heater treater. You have, just to optimize your separation, also implement this electronic level control with the heater treaters. There's a couple different ways it can be done, and we have not yet tried it yet, but it's definitely one of the next things that we're hoping to implement. Because this also, having an efficient dump off your heater treater will improve your measurement accuracy if you are measuring downstream of the heater treater output. The tank gauging we have everywhere in our 2 big shell plays, and they've been great. They're very accurate, and I've convinced the field of that, and they finally got them off the tanks, as I said earlier. So we have some wired, some wireless. It just depends on how the decision was made at that point. But they've been highly accurate, and I've had some test comparisons done, and they've been great so far. And the batteries haven't died yet. Our lacting is currently using a PD, a positive displacement meter, and this is kind of out of our control at this point for this field that it's used in. So there is a solution to have a Coriolis meter and a fancier package, automated package available, but we haven't gotten there yet. And then emissions is very, very hot topic and very important, especially in these shale plays. So we do have attached to all of our tanks and a vapor recovery unit. So any blanket gas isn't just vented to atmosphere, it actually goes through a system. And we have to keep control of those numbers to report to the EPA and some of the other local regulatory agencies. And this is one of the technologies that's been proposed but not tested yet in our field. A couple more minutes. So we did the big study to see what is currently done, what are the day-to-day tasks, and the main goal was to figure out a human-centered approach to make these tasks easier, more efficient, more effective, and the very important thing, just make it easier for the field, reduce the amount of tedious tasks that they have to do, and make their time and work more valuable to where they can help optimize wells instead of fixing everything or being data keepers. And we're hoping to stop retrofitting after the fact these solutions just one by one, piecemealing together. And as we drill more wells and enter new fields, have a package approach and say, this is what we're putting on and it's going to do everything. So I think that's it for now, but we'll have time for questions at the panel part. Thank you.